No, we're here. Co-Life is... Hey, everyone, and welcome to this week's edition of the Jitsi Community Call. We have a pretty cool talk ahead of us about encryption, end-to-end encryption in Jitsi, and WebRTC in general. We have people here that's going to talk about the existing implementation in Jitsi, and then Saul will talk about our next steps with end-to-end key negotiation. Before we start, very short update for things that we've worked on since past week. Lobby Rooms is getting really close to delivery. We just have a few final tweaks that we need to iron out. And Jaya wanted to add something as well.
Yeah, so we've added the ability to actually set the max resolution on the client side. So we've added a method on Jitsi Conference where you can say what resolution you want to set. So if you're in a non-simulcast case, we'll just change the local track resolution. But if you're doing simulcast, we'll send all the streams up to that max resolution. So this is a simple change. And for the Jitsi Meet client, you can actually control it via the settings in the video quality settings. Or if you're a libjitsi Meet user, you could change it using set sender video constraint. Yeah, that's it for me.
Sounds great. Thank you very much, Jaya. This is it for the update. Now we're going to move to the talk from Fippo and then Saul. Just as a reminder, we were supposed to do a presentation about the way we run infrastructure for Meet Jitsi. This is now postponed for next week. And now we're talking about end-to-end encryption. Also, your questions are welcome on YouTube. You can get there. Well, if you're listening this, you're already there, so I'm going to spare you the instructions. And with that, Fippo, take it away.
Thank you, Emil. So 4 weeks ago, we did this demo call between Jana, Saul, and me, and then you joined. And you saw only this, well, garbage.
I did.
And you didn't enjoy it.
I wouldn't call it garbage. I think it's pretty cool, but you can call it whatever you want.
Yeah. And that was the first demo of end-to-end encryption in Jitsi Meet using the new WebRTC Insertable Streams API. And that is a new API that just landed in Chrome 83. And what it does is, instead of taking the normal...
So, Fippo, can you go back to the previous screen? I want to make sure that everyone understands what they're seeing here. So, what you see here is the three squares that I appear. This is my view, right? So the three squares that appear as garbled are Fippo, Jana, and Saul, who are exchanging media after entering an end-to-end encryption key, which has the advantage that to protect their audio and video data from, well, to begin with, people who don't have the end-to-end encryption key, which is not particularly interesting because you can already achieve that with a simple password. But really the more interesting thing here is that this is what people intercepting the streams on the server would also get. So this essentially, this call, the end-to-end encryption portion of it, is unassailable by the service provider, which is really the whole the whole point of doing this. Sorry for the interruption, people.
Yeah, and it is a small change in the API. So typically we have our media stream, which is consisting of an audio and a video track. We feed it to the encoder. And now we get this insertable stream bit, which we're going to see in a bit, which is a function that allows us to do stuff with the encoded frame that we get. And then it goes to the RTP packetizer, then it goes to the DTLS encryption part, and then to the network. On the other end, a packet from the network gets decrypted, depacketized, and then we get our insertable stream callback. Then it gets decoded and goes to HTML media element. So that is a very simple API, but a very powerful API. So we can see the code here. It's just 100 lines of code that takes this encoded video frame and then does some encryption with it. And we have documentation on the packet format, but basically it's leaving some bytes unencrypted, enough that the bridge can route the packet without any modifications. So it doesn't even know that there's encryption on the packet. And then it uses web crypto to encrypt the packet with AES GCM.
So people, what you just said might maybe raise a couple of eyebrows. What? There are a few bytes unencrypted. Could that involve leaking information? What is in these several bytes?
It depends on what the packet is. So for audio, it's just the first byte of the packet, which in Opus is a special table of contents byte. So you're not leaking much information there. There's no user-generated information in there. It's just what Opus or Silk mode is this? Is it a stereo thing or not? And for video, the number of unencrypted bytes depends on the frame type. So for keyframes, it's 10 bytes because there's a 4-byte header, and then that's followed by another 6 bytes of information. And for non-keyframes, it's just 3 bytes out of 3,000. So the unencrypted amount is really minimized.
Thanks.
And thanks to Saul, we have 2 ways to set it. One is this nice API, this nice user interface, which you can see if your browser supports end-to-end encryption. You can choose it from the menu, and it will be available in Chrome 83. It is still experimental.
Chrome 83 is currently, I'm sorry, I'll keep interrupting you just because that's how I am. Chrome 83, that's currently Chrome Beta. So if you're running Chrome Beta, you will get this option in your ellipsis menu in the lower right corner of Jitsi Meet.
But only if you have experimental web platform features. Otherwise, you won't see anything.
Oh, on Meet Jitsi, it's enabled by default because there's an origin trial. So Meet Jitsi is a special domain for Chrome now, and it enables this feature for everyone. And you can either use that UI or the hash E2E key equals something setting in the URL to set the key. And from the user inputs that we get, we derive a 120-bit AES key, which is then used for encryption. The problem that we currently have, it's a shared key, because we have no secure way of exchanging that key. And it's going to be a set of keys, one for each participant, very soon. But the problems that we haven't solved yet is how to exchange the key in a secure fashion. So that's currently up to you. But you can send the URL, including the hash E2EE key, to a friend, and then the Jitsi video bridge cannot listen into your conversation.
Right, and there's a few ways you could do that securely, right? So, which is partially why we decided to release this feature even in its current shape. Ideas that might appear approachable to people are just sending it over an end-to-end encrypted form of chat, like Matrix, for example, or Signal. Or you could just exchange it when you're actually physically communicating with someone, and then just remember to use it the next time. Even if you encrypt it, so here's the thing, even if you send it over a different channel that is not end-to-end encrypted, but is simply not available to the same provider as your video service, that kind of splits the keys in a way where none of the two actors can access the content. So the feature has value, even though the automated key negotiation isn't there yet. Obviously, things would get better with it, and we'll talk about that a little bit better later.
Yeah, and there is a nice demo in the WebRTC samples that shows what the Jitsi video bridge or someone listening on the Jitsi video bridge would see. And it's just this stream of garbled video, which is very nice to watch. You can watch it for hours, but you can't really gather what people in the meeting are doing there. which is great. And one of the coolest features of the implementation is that it is using a worker in Chrome. And you can see if you open the Chrome DevTools, go to the Sources tab, you will see a E2EE worker, which contains the whole code that is used for encrypting and decrypting. And it also does manage the keys, so you can set breakpoints and see when it's used and how it's used. So it's very easy to verify that you are encrypting, how the encryption is done. And it's just, I think, less than 200 lines JavaScript even. And that is how we made end-to-end encryption. And the next problem is, how are we going to exchange the keys over the signaling channel?
So let's talk about that for a sec then, shall we? Our current plan is what we really want is to establish a channel, secure channel amongst all the participants that is end-to-end encrypted. And then the high-level idea is that every participant will generate a random key and exchange it over this channel and reuse the encryption mechanisms that Fipo told us about. So right now, there are two, let's say, big candidates to use this. I'm going to talk about, they both solve the same problem, and we're going to go with one of them, at least to begin with. The two sort of candidates are MLS, which is it's a working group that is working on standardizing this an end-to-end encrypted transport for arbitrary data. They have very interesting primitives, but it's still there's not many implementations yet, and it's work in progress. And then we have OLM, which is the end-to-end encryption library by the folks over at Matrix. And well, Matrix has been around for quite a long time at the moment, and OLM seems to solve the problem we need to solve. So right now we're focusing on integrating OLM. And the way this would look like is each participant will create, using OLM, their two sets of keys. And then in pairs, you will end up establishing a secure channel with every participant and have a shared secret with them. And then thanks to all these bilateral connections, you're able to now create a meg-olm ratchet, which allows you to encrypt something for everybody. So it's end-to-end encrypted for the group. So what we are, our current plan of attack is we're going to use this OLM-based channel to securely exchange a randomly generated key. And then this is the key that we're going to use to do the actual encryption of media. So by piggybacking on the crypto and security properties of OLM, we end up with a secure key we can use to encrypt all our media. And of course, if we kick someone out, for example, we don't want them to be able to decrypt media any further. So we're going to rotate the keys when with join and leave operations, and maybe even at intervals. We still need to iron out all those details. So once we have all these bits and pieces in place, what we would end up having is an end-to-end encrypted mechanism by which we exchange those keys, and then we have all the media encrypted. But this is unverified encryption. So we know all the data is encrypted and nobody can tamper with it or snoop into it, but we don't know exactly if the person on the other end is who they claim to be. For this, we need a verification mechanism, and we're going to focus on that as a next step. There are a number of options on the table, like using an identity provider. We could use Matrix itself, for instance. We could also make it so we maintain fully the deniability of every participant. So with every session, all the crypto materials are destroyed. we need to see what makes sense for the scenarios we want to focus on. But this is basically the directions that we're going to take at the moment. And I think that pretty much sums it up.
All right. So there's been a few questions in the chat that I'm going through now. There's one that asks about how does Jibri come into play when end-to-end encryption is enabled? And that's a great question. So right now, that dialogue that Fipu showed earlier in his slides tells you that server-side provided functionality is simply not available in an end-to-end encrypted call. There are ways where you could potentially, with the consent of the user, try to extend end-to-end encryption keys to such elements. Right now, we're not doing that. And the thinking is that, in an end-to-end encrypted session, really, so let me take a step back. Without end-to-end encryption, the only entity that has access to your media is the provider of your service. So in Jitsi, that would be us. And the point of adding end-to-end encryption is so that you would make your data unavailable to us. We're not able to read it and understand it. So if you're going to use us to then record it or forward it to a telephone call or live stream it to YouTube, then you're going to have to trust us with your data. And the easiest way to do that is to simply remove your end-to-end encryption, which will still keep your data protected from everyone else because it's encrypted by just DTLS-SRDP as per the WebRTC specification on the network, and no one can access it there. So at this point, our answer to this is no. If you're using server-side assisted services, you're just going to have to turn off end-to-end encryption. Again, there are nuances there, and we may look into that in the future, but for now, this is the answer. There are a couple of questions about whether this is an exclusive Chrome feature, and are there any solutions for Safari or Firefox? Why don't I stop talking and let someone else take this one?
Well, it is very experimental, and it's only available in Chrome currently, but we will, of course, talk to the Firefox and Safari people. I think it's already available in the new version of Edge, which is Chromium-based.
Yes, it is.
So it will happen, hopefully.
So, sorry, go ahead, Saul.
I was just going to add that it was presented, if I recall correctly, at W3C TPAC 2019. So it is, as far as I know, it is following the usual standardization path. But you know, it's relevant enough in the present day to put it in the hands of developers to begin with. To iron out stuff, I know you people have been reporting to Google all sorts of stuff that we run into on this. Those 100 lines had tens of bugs, and Google was very quick at fixing them. So like this interaction was actually beneficial for the spec itself. And so at the end of the day, this is the process that we're following. It is expected that when it becomes a standard, also other vendors join in.
Right. And please do contact your local Firefox representative and ask them for support of insertable streams if this feature is important to you. There's another question about, from an end user perspective, does the user need to use a tool to generate the encryption key? And the answer to that is no. In the current way this works is that the end-to-end encryption key is supposed to be entirely user-generated. You can use a word that you're all comfortable with. That's probably the easiest, especially if you're going to be manipulating it in out-of-band ways, especially if you're going to be saying it somewhere. Now, you might want to make sure that this is a complex combination of characters, just as you would generate a password. You could use one of our 4 words combinations that we offer as meaning names, or whatever you're comfortable with, but you absolutely don't need to use a key generation tool. That's not that kind of key. Oh, right. Let me see if there are any other questions. In the meantime, if someone wants to add anything, please don't hesitate to do that.
I think we should add one thing, which is in addition to these not being currently available for Jibri or PSTN participants, it's also not available for mobile participants right now. It is because the way we do our video on mobile is by wrapping the WebRTC library ourselves in a React Native module, and we would need to basically create the insertable streams API there or something alike that makes sense for that scenario, because probably the performance implications in the React Native case are going to be interesting to deal with. So that is bound to happen, but it's not available yet either.
Yeah, but the API for that is already available in the WebRTC native library, so
yeah,
it shouldn't take too long.
No, that's correct.
Okay, looking for other questions. There's a question about whether when end-to-end encryption is enabled, one could record all the encrypted data and then leave it to watchers of the stream to decrypt it. And the question was specifically about Jibri. So the answer to that question in the context of Jibri is no, because the way Jibri works is that it needs to actually render the conference and record the rendering in a simple, unidimensional video file. It is indeed architecturally valid. It makes sense to have what is described here, to have a server-side recorder that would simply do a packet capture and record the encrypted packets, and then users with the key will be able to watch them by supplying the key to a player. In theory, that would work. In practice, that would require some sort of a player or post-processing tool that would take all these streams, would decrypt them, then render them, then stitch them together in a viewable recording. And that's a very, very hefty project. It was actually something that we were looking to do 5 years ago. The remains of that project, Code Popro, I think, are still around at GitHub. But it ended up extremely time-consuming, and that's why we went down the Jibri path. So if someone out there in the community wants to give this a try, go ahead and do that. But at this point, we have no plans to tackle the recording that way.
There's also the added difficulty if you would need to record the keys every time they rotate and change them in post-processing so there are no gaps in the video. That sounds very, very tricky to get right.
Yes, we know that the Meet Echo guys have added support for this kind of recording in Janus, but that is just for a single stream.
Okay, so next question. Have you considered going to AES 192 or 256? Most crypto policies increase trend over the years. 128 is at the bottom of the scale. Who wants to take this one?
I nominate Jonathan.
So generally, all the policies I've seen have been that for transient keys like media, where this is not something where you have to expect. This is something that you need to keep this needs to be secure for decades. Something where you have a meeting and probably that's it. Generally, AES 128 is considered perfectly secure, and because as I saw, there's another question. There's some concern about the CPU usage. AES 128 is perfectly fine, good enough, and for these purposes, and will be less computationally expensive. But if somebody if you want to change it once it's deployed, it should just be changing one parameter in the code to switch to a higher key length if you feel like that would be good for your use cases.
Jonathan, can you talk a little bit about scenarios where it is accepted that AES 256 makes sense?
Generally speaking, what I've heard is things where you want your security model is this is something where, somebody throwing, decades of, it's so important that, even if somebody throws decades of compute at you, you still want it to stay secure. So like, top government secrets and the like. Generally, everything I've seen, and for all practical uses, people generally want to use AES 128. Now, mind you, I'm not a crypto expert, so if somebody tells me though that this is wrong, we still want to do a crypto review on this whole process. So maybe we'll discover that somebody says, no, you do want to use AES 256, and like I said, that's just a matter of changing one parameter if that turns out to be the case.
Right, and we may actually make that easily configurable in the code so that people who want to deploy it under different circumstances would be able to do so easily. Thanks, Jonathan. There was another one about, is there any change to the video bridge in order to support end-to-end encryption? And the proud answer to that is no, none whatsoever. That's the whole beauty of the scheme. For a little bit of history, traditionally, the way that video conferences used to work was this central entity that would receive all streams and decode them and then stitch them together in composite images, kind of like Jibri does today in recordings, but that was happening at the center of your conference, and then re-encode them and send them back as a single stream. This is what people refer to as the MCU. It is that wouldn't have been possible there at all. Now, what became interesting in the past 15 years was that the general approach to video conferencing changed and people switched more toward video routing. This is what most of the major players, with one or two exceptions, are doing today. And with that, it essentially became unnecessary for the provider to even know what the content is. So the fact that end-to-end encryption is not widely available today is not really for any other reason than, I would say, it's not for a core reason. It's just for the inconvenience of having to deal with, the implications of encryption and the user interface and the key negotiation and all these things. But architecturally, this became possible exactly because things like the Jitsi video bridge do not need access to the media. So again, in this case, no such thing is necessary. So there are a few questions here that are non-end-to-end encryption related. I'm going to keep them for the end. There's one that talks about post-quantum encryption. Let's be clear that sure, all existing crypto in the world today comes with a question mark as soon as quantum computing becomes available. This is not where we are as a species today. So, we'll just worry about the problems that we have once quantum computing becomes a thing. I'm sure that there's going to be people that would worry about making quantum computing resistant standards at that point. So I'm not seeing any other end-to-end encryption questions here. So there's a few with regard to general Jitsi utilization. There's a quick one. Which codec do we use? We use VP8 at this point. There's work ongoing on VP9. AV1 is still a bit too early. Then there was one talking about instance sizes. That's a question that comes back really often. We should probably have a quick answer about it. Ours are, we used to be running until recently with 2 core machines with 8 gigs of RAM. 4 core
machines with 8 gigs of RAM.
Oh, were they?
Yeah.
Okay. Until recently, though, we switched for not because the conferences required it, just for other logistical reasons. So we currently run the bridges on. Aaron?
Sorry, I was distracted. Can you give me the question again?
We currently run the bridges on
4-core machines with 8 gig of RAM.
No, I thought we changed that.
No, 4-core machines with 8 gig of RAM.
Okay. Then I'm mistaken. So let's see other questions here. I don't actually see anything else that would be suitable for this part of the call. We're going to drop in our usual gathering spot, me, Jitsi / the call, in a few minutes for informal discussions. I'm going to give a few minutes to people who want to ask any additional questions. Oh, there's one I see. Is open source Signal being used for end-to-end encryption? So this is something that Sue talked about earlier. So I assume the question pertains to the double ratchet algorithm that Signal uses for key negotiation. Again, key negotiation is out of scope for the current implementation of Jitsi. And yes, we are planning to use matrix.org's libOhm implementation of the double ratchet algorithm for the next phase of key negotiation, which is what we're currently working on.
Was the question, Emil, about Signal with capital S or Signal as in signaling things?
Oh, it was a capital S. So
I asked because the reason why we didn't look at that one is because it's GPL, so it's not compatible with our license. We cannot use it. But OLM is MIT or Apache licensed, I forget right now. And that's why they implement the same algorithm as far as I remember, or really, really close to one another. And that was actually the main motivator to pick it over libsignal.
I also saw one question about end-to-end asking what the CPU overhead was.
I'm still working on that, and it looks like, I think, 0.4 milliseconds per frame. So it's not that big, but we still need more data and more statistics on that before we can give a final answer. So we actually asked the Chrome people to get us better statistics for this. But it should not be too big.
all right, so that will conclude this section of the call. Thank you, everyone, for joining.
I just want to correct myself here. Emil was totally right. We did change shapes, and the newer bridges are running on 8-core machines with 60 gig of RAM. So, Emil, you were absolutely right. Sorry about that.
Oh, thank you, Aaron. So we'll meet you all. We'll find you all in the Meet Jitsi / the call for additional discussion. And for now, thank you all very much for joining, and see you again next week. Bye-bye.